Hi, I'm Gary and welcome to another episode of TechBites. Generative AI tools such as Midjourney and Stable Diffusion allows users to easily generate images with just a few prompts. For example, you can ask Stable Diffusion to generate an advertisement brochure of a koala and get these images as an output. However, instead of a general prompt like this, what should we do if we want to insert my own face or my company's unique products into an image? In the popular movie Titanic, Rose asks Jack to draw me like one of your French girls.
Jack, I want you to draw me like one of your French girls.
A request for personalized image generation. Now, if this was to happen in today's modern world, Jack could achieve this through the process called Textual Inversion, though a bit less romantic. We will take a look at some possible business applications, and we'll also guide you through the process of textual inversion, GPU access, and prompting. Before we dive into the process of textual inversion, let's first see how textual inversion could be used in business settings. With the help of textual inversion, it is possible to customize both objects and styles. The use of customized or personalized image generation could be used in businesses to quickly generate early prototypes of artwork, interior design, or an advertisement. Imagine making early prototypes of your ad with your very own product with just a few prompts. Here's an example of an advertisement brochure containing a little white bird statue, generated through the process of textual inversion and stable diffusion. Diffusion models such as stable diffusion or latent diffusion take in prompts as input and output images accordingly. What happens inside the diffusion model is that it splits all the words into sentences and puts the words through an encoder. The encoder then turns all the natural words into real numbered vectors called the embeddings. Let's think about the relationship between the words king and queen. What comes to your mind? What comes to my mind is that they are both monarchs but with different genders. Do you think computers could understand these slight nuances to words? In fact, computers understand these nuances and details just like how we humans do, but in a slightly different way. We process words as themselves, but computers process words after converting them into numbers. In natural language processing, words are represented as embeddings, which are vectors of real value numbers. This embeddings representation helps the computers understand the human language. Embeddings can capture the details of a word or a phrase. For example, in the embedding space, the relationship between the words man and woman is the same as the relationship between the words king and queen. We can see that the embeddings have captured all the details of gendered words. The embedding space can not only capture the gender, but also the various relationships between words, such as grammatical changes and the relationship between a country and its capital city. Now that the sentence is split and the words are represented in numbers, computers can understand the semantics or the meanings of the prompt. The diffusion model is then fed with the embeddings, producing a set of images as output. Now that we've went through how diffusion models work, I'll walk you through how we can incorporate a personalized concept into the diffusion process. Textual inversion is the process of capturing the novel concept with a small number of input images by creating a custom embedding, which is sort of like a pseudo word. Let's input the textual inversion model with, say, 4 different paintings of Vincent van Gogh. The process of capturing the essence and the details of the Van Gogh paintings as an embedding is called textual inversion. After textual inversion, we should have an embedding S star, a set of real numbers that contains the essence of the Vincent van Gogh painting style as the output. Now that we have found the embedding for our new concept, we can go back to our diffusion model and input a prompt that contains the pseudo word into the diffusion model. These are the final outcomes from the stable diffusion with our prompt, a painting of a cat in the style of S star. We can see that it has captured the essence and the details of some of the Vincent van Gogh paintings pretty well, especially the texture and the colors that Van Gogh frequently used in many of his paintings. The pseudo word S star can either be a style or an object. The more images we input, the better results the generative model will produce, but it will also make the process much more computationally expensive. There are 2 major perks of using textual inversion instead of retraining the entire diffusion model. First, retraining a diffusion model is very computationally expensive. Moreover, fine-tuning on a few examples could lead to catastrophic interference. Catastrophic interference is the tendency of an artificial neural network to abruptly and drastically forget previously learned information upon learning new information. especially if the size of the input images are small, as in this case. Textual Immersion requires a diffusion model. The diffusion model used could be any diffusion models out there, including Stable Diffusion and Latent Diffusion. We can use the Stable Diffusion API provided by Hugging Face to achieve textual immersion. However, when using the Stable Diffusion API, we should make sure that the version the embedding is trained on should be the same as the version of the model that is used to produce the images. The Van Gogh example in this episode is trained for 2 hours on GPU access. Without GPU access, the training speed could increase significantly, adding up to more than 10 hours, since training and embedding is still very computationally expensive, even without retraining the entire diffusion model. Thus, GPU access is very important for training for textual inversion, just like any AI and machine learning models. If it's difficult to find yourself a computer with a good GPU, we can easily use online services such as Google Colab, which provides both free and premium GPU access. Feeding the right prompts to the diffusion model is vital to getting the desired results. A good prompt contains the details of what the user wants. The details include subject, medium, style, artist, resolution, color, and lighting. Another strategy to get the desired result is to use negative prompts. It's basically telling the diffusion model what not to include in the results. If you're getting undesired results, find out why you don't like them and include that in the prompt. Some examples of negative prompts that you don't want to keep include bad anatomy, bad proportions, blurry and cloned faces. Note that a lot of generative models still perform poorly in drawing human hands at the current stage. Although textual inversion and generative diffusion models could be very useful in many situations and different business settings, the users must note its possible ethical concerns. Since it is sometimes difficult to tell real images and AI-generated images apart, it would be the user's responsibility to make a note for other people that it is an AI image, in order to prevent the spread of false information. Also, the style or some details of generated images could lead to copyright infringement. It will be important for the users to note the possible ethical concerns before publishing the generated images. So going back to Titanic, although Jack is not here anymore after the tragic sinking of the ship, we can still generate a drawing of Rose in the style of Jack's paintings, with the use of personalized text-to-image generation. If we have 3 to 5 images of Rose and 3 to 5 images of Jack's previous paintings. I can't wait to see how you would personalize your own images, and that concludes the video. I'm Gary, and thank you for watching this episode of TechBites.